The Big Bang theory has lost some validity with the new information discovered by the James Webb Space Telescope, which has made a surprising discovery that is revolutionizing world physics. The recent image captured by this telescope has generated compelling arguments that have surprised experts, putting an end to much speculation. The telescope's most recent discovery is visually stunning and could transform our understanding of the universe. The discussion among experts that this image has resolved centers on the perception of the cosmos. The stunning image taken by the James Webb Space Telescope challenges our understanding of the universe. This finding addresses one of the main problems in astrophysics, the age of the universe and its rate of expansion. Scientists of different generations have been puzzled by this unsolved phenomenon and have carried out numerous studies in search of answers. Cosmologists investigate how the world originated, how it works, how it has changed over time, and how it will end. In the last 100 years, great advances have been made in this field. The Big Bang theory, the most widely accepted theory in cosmology, holds that the universe has been expanding for approximately 13.8 billion years, starting from an extremely hot and dense state. The Hubble constant, which indicates the expansion rate of the universe, is used to measure its growth. However, determining how to measure the Hubble constant is not straightforward, and there are two main methods: local measurements and measurements of the early universe. In space, objects such as stars and Type 1 supernovae, which are used as standard candles because of their constant brightness, allow astronomers to measure how far away they are and thus calculate the Hubble constant. As the expansion of the universe varies in speed, scientists can calculate the Hubble constant. There are two main approaches. One is the measurement of the early universe. Scientists use reading of the cosmic microwave background radiation, CMB, discovered in the 1960s as the afterglow of the Big Bang. This microwave energy comes from when the universe was only 380,000 years old. Astronomers can determine the age of the universe and its expansion rate by measuring the tiny ripples of temperature and polarization emitted by the CMB. However, there is a problem. These methods do not yield the same result. Local measurements suggest that the universe is expanding faster than the CMB data indicate. Scientists have been hard at work trying to understand why the results differ. To unravel more mysteries of the universe, more studies are underway. The differences in measurements indicate that we do not yet know all the science or that there are errors in one or both methodologies. But thanks to the James Webb Space Telescope, we can peer farther into the darkness of space than ever before, revealing elements, planets, and galaxies we never thought possible. Scientists hoped the data found would help them calculate the Hubble constant. But the first wave of data has revealed new things that don't line up with our expectations. Could this information give us a new perspective on space? We may need to rethink what we know about how the universe works. We might discover particles and forces never seen before, or find that dark energy, an unknown force that accelerates the expansion of the universe, needs to be reconsidered. With each new discovery, our ideas about space have evolved. For example, the cosmic microwave background radiation discovered in 1965 was a strong proof of the Big Bang theory. Before that, scientists thought the universe would last forever, growing at the same rate indefinitely. However, new evidence showed this way was not the case. In the late 1990s, when we discovered that the universe was constantly expanding, we also learned about dark energy and its impact on its expansion. Every time we discover something new, we check whether it fits with our previous knowledge and generate new ways of understanding the universe. If it were not for this, the problem we face in cosmology could lead us to find better ways to understand the universe. Although this problem is complex, it is also exciting because it drives us to develop better tools to explore space. Scientists around the world are interested in this cosmological problem because everyone wants to know more about the universe. Most importantly, this demonstrates how science is always evolving as we learn more about space. SA tension is another concept that goes hand in hand with Hubble tension and refers to how matter is distributed in space. We use this information to create a structure of the universe and see how it has changed over time. Some areas of space have many galaxies clustered together, while others do not. Scientists use different methods to determine the magnitude of this dispersion. One possible way to address this is to look at how different densities of matter, such as galaxy clusters, bend light from distant galaxies. This phenomenon, known as gravitational lensing, allows us to see whether the dark matter is, which does not emit light and therefore undetectable. Scientists also analyze the cosmic microwave background, the CMB radiation, and afterglow from the Big Bang. This light has traveled for about 13.8 billion years, carrying information since the beginning of the universe. By studying the CMB, scientists can understand how the universe was full of irregularities when it formed. However, there is a problem. This data does not match the large-scale irregularities observed in the current universe. The non-spherical distribution of gravity suggests that matter in the early universe was more uniform than seen with gravitational lensing. This suggests that there is something we are not considering in our interpretation, which brings us back to the idea of dark matter and how it works. According to Risi, he and his team were able to redefine their work thanks to the Webb Space Telescope and wanted to find out if a possible error in the Hubble Space Telescope measurements could be the cause of this discrepancy. However, the JWST showed the same deviations, which is worrying. Somewhere between these two observations, there must be a fundamental flaw in our understanding of the universe, Risi said in an interview with an astronomical magazine in the United States. Using the new Space Telescope has allowed us to look deeper into the universe through its sharp infrared view and study cosmic distances with ever more precision. Both dark matter and dark energy are enigmatic components that make up a significant part of the universe, but their nature remains elusive. While black holes have been the leading explanation for certain gravitational effects, there is growing interest in exploring how dark matter and dark energy could influence these cosmic phenomena. What is exactly the observable universe? The observable universe refers to the portion of the universe that we can observe and study using telescope and other instruments. However, this capability is limited because light, the main source of information about the universe, can only travel at a finite speed. As a result, we can only observe objects and events that are at a certain distance from us. We cannot directly see objects or events that occurred long ago in the past. The diameter of the observable universe is estimated to be approximately 93 billion light-years, which is much larger than the estimated age of the universe, which is estimated to be 13.8 billion years. This discrepancy is because the expansion of the universe has caused objects that were once close together to move away from each other, and light from those objects has required more time to reach us. Overall, the observable universe is a vast and fascinating space, but there's still much we don't know about it. However, through the use of telescopes such as NASA's James Webb Space Telescope and other scientific instruments, we continue to learn more about the structure, composition, and history of the universe, as well as its various phenomena. Join us as we discover the NASA structure that the James Webb Space Telescope has just made contact with in the far reaches of the observable universe. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Now, what lies beyond the observable universe? To reach the far reaches of the observable universe, we would need to develop transportation methods that would allow us to transcend space-time, such as using distortion engines or wormholes. These concepts have long been the subject of debate among scientists, some of whom believe that they are simply impossible or they contradict the idea of faster-than-light speed travel. The feasibility of both possibilities, faster-than-light travel and the use of advanced technology beyond the reach of current human intelligence is a subject of intense debate. Even if it were theoretically possible, it would require technological advances and machinery that are currently beyond our capabilities. The theory of cosmic inflation posits the total size of the universe is at least 10 to the power of 23 times larger than the observable universe. This number is so vast that it is incomprehensible to the human mind, since we cannot see or measure the unobservable part of the universe. Therefore, we have no way of knowing with certainty what lies beyond its limits. However, that does not mean we cannot develop theories based on the information we have gathered from distant galaxies, and this is where NASA plays an important role. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Space Telescope became operational this year, NASA had already released images of the ultra-deep field obtained with the Hubble Space Telescope. However, when the James Webb Telescope made its debut, it was taken out to observe the most distant galaxy ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos, apparently as they were millions of years after the Big Bang occurred, approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Space Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. The James Webb Space Telescope has made observations of several fields of distant galaxies, allowing scientists to study the rate at which stars formed in the early universe. These data reveal the existence of a significant population of galaxies that were forming stars in the early stages of the universe. These discoveries are truly fascinating and thought-provoking. For a long time, humans have contemplated the possibility that we are not alone in this vast universe. However, these new determinations within the observable universe leads us to believe that there must be millions of galaxies in the unobservable part of the universe. This idea is truly shocking and awakens a sense of awe and wonder about the vastness of the cosmos. Are there extraterrestrial beings somewhere in the universe? The likelihood of life beyond Earth has never been more compelling, leading us to consider the possibility of the existence of extraterrestrials. There are numerous planets outside our solar system known as exoplanets, which have been discovered using techniques such as the transit method and the radial method. Some of these exoplanets may have similar characteristics to Earth and may harbor life. This theory has been supported by another discovery made thanks to the James Webb Telescope related to the exoplanet WASP 96b. This planet is outside our solar system, and its light spectrum revealed something surprising: the presence of water molecules. In addition, the spectrum also shows hints of haze and clouds, which were not previously thought to exist on a habitable planet. Based on the habitable environments found elsewhere in the universe, and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet. Although we do not yet have conclusive proof, discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility. What about the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. The multiverse is mainly discussed in the context of quantum physics, which deals with the behavior of tiny particles such as atoms and subatomic particles. According to some interpretations of quantum physics, the act of observation can cause a quantum system to collapse into a single state. However, in the many worlds interpretation, The act of observation simply causes the system to split into multiple states, each representing a different outcome. It is important to note that the idea of the multiverse remains highly speculative and is not yet supported by conclusive evidence. It is therefore difficult to state with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical about its validity. Given that we do not know what lies outside our universe, the possibility of the existence of a multiverse remains as valid as the famous Schrodinger's cat thought experiment or the nature of darkness. It is a concept that arouses fascination and reflection, but requires more research and evidence to be confirmed. Does the phenomenon known as dark flow exist? The question is complex and raises an intriguing issue. Dark flow came about in 2008 as a possible explanation for the observation that some galaxies clusters appear to look faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these galaxy clusters may be influenced by some form of dark matter or dark energy that pulls them in a specific direction. However, the existence of dark flow remains controversial and has not yet been accepted by the scientific community at large. Some studies have suggested that dark flow may be real and could be caused by the presence of a massive structure in the universe that exerts an attraction on galaxy clusters. However, other studies have failed to confirm the existence of dark flow and have proposed that the observed motion of galaxy clusters could be the result of other factors, such as systematic errors in the detected ones. While other studies suggest its possible existence, we cannot say with certainty its presence outside the observable universe. More research and evidence is needed to better understand this intriguing phenomenon.
Since time immemorial, mankind has asked itself a question that arouses great fascination. What lies beyond what we know? What exists beyond the limits of our universe? The answer is extremely complicated, yet the James Webb Space Telescope has discovered something massive and fascinating in the far reaches of the cosmos that could revolutionize physics. What exactly has the James Webb found at the edge of the universe? Why are scientists so excited? We invite you to join us to explore how this telescope has discovered something gigantic at the limits of what we can observe. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Albert Einstein developed the theory of gravity that revolutionized Newton's theory, and in 1916 he applied it to the universe. This theory showed that the universe could not stand still and must be in motion, expanding or contracting. In 1929, the astronomer Adrian Hubble observed that the galaxies were moving away as a result of the Big Bang. This is the expansion of the universe, where the distance between galaxies is constantly increasing. Einstein's theory can easily explain an infinitely expanding universe, or one that curves back on itself like the surface of a ball in a higher dimension. Some argue that the universe has an edge, since it was born in the Big Bang 1382 billion years ago. Therefore, we can only observe galaxies whose light has traveled a distance in less than 13.82 billion years to reach us, forming a spatial sphere centered on Earth, called the observable universe. In reality, the universe is 92 billion light years across, and the limit of the observable universe is the cosmic horizon, similar to the horizon of the sea, and we know that there are an infinite number of galaxies beyond it, but their light has not yet reached us. Can James Webb Space Telescope see the edge of the universe? Being 100 times more powerful than Hubble, it can detect the faintest infrared light from the earliest galaxies in the universe, as well as planets and other stars in their habitability. However, we do not yet know what the telescope will observe when it's pointed towards the edge of the universe. The universe is divided into the observable and the unobservable, with the observable being everything we can see by detecting radiation with our eyes, and the limit of the observable being the cosmic microwave background that was produced 13.8 billion years ago. At that time, the universe was opaque, like a dense fog. Some experts believe that there are gravitational waves and neutrinos coming from even more distant places, although this cannot be verified due to the lack of technology. Cosmologists suggest that to better understand the universe, one must consider that what we observe is only a small part of a larger reality. Finding galaxies like Abell 2744y1, which lies at the farthest edge of the universe, can help us better understand this reality. Although this galaxy is so far away that it takes 13 billion years to reach us, scientists can observe it in its youth, some 650 million years ago. The Spitzer, Chandra, and Hubble telescope work together to discover this galaxy, as each uses different parts of the electromagnetic spectrum to capture data. By combining data from all three telescopes, astronomers can examine galaxies that are up to 100 times farther away than any telescope could have observed on its own. Astronomers from the Astrophysics Institute in Canarias and the University of La Laguna used the Hubble Space Telescope to discover the galaxy Abell 2744y1 and calculate its distance and number of stars using Spitzer equipment. They also use the gravitational lensing technique, which is like a magnifying glass that focuses light from distant galaxies through galaxies closer to Earth. The galaxy is small compared to our Milky Way, with a width of about 2,300 light-years, but its star creation rate is 10 times that of the Milky Way. The redshift of the galaxy Abell 2744y1 is 8, indicating that its light has been pushed toward redder wavelengths due to the expansion of the universe. Before the discovery of Abell 2744y1, the farthest known galaxy had a redshift of more than 7, but now astronomers have found something even farther out, a supernova called DES 16C2NM, identified through a dark energy survey. Supernovae are incredibly massive explosions, representing the last effort of a star before it dies. To understand how stars work, we must observe their death. Massive stars burn enormous amounts of nuclear materials in their core, which generates a large amount of energy. This energy creates pressure that prevents the star from collapsing. When you see a star in the night sky, it is because there is a balance between two opposing forces. Massive stars have a constant struggle between gravity, pulling them inward, and the energy released by nuclear burning, pushing them outward. When the star runs out of fuel, it begins to cool and the pressure decreases, allowing gravity to take over and cause the star to explode into a supernova. This process happens quickly, in a matter of seconds. When two stars collide, a supernova can also occur. The DES 16C2NM supernova is extremely rare and was discovered in 2016 by a multinational team of astronomers. That star is a Type II supernova star, which means that it has reached the end of its life and has exploded in a cataclysmic explosion. The explosion is believed to have occurred about 10.5 billion years ago, and light has traveled to us for more than 3/4 of the history of the universe. Due to the expansion of the universe, the supernova is much farther away than it appears to the naked eye. The DES 16C2NM star was particularly interesting because it was a dark supernova, which means that it did not emit much visible light and therefore was difficult to detect. However, it was possible to detect it using telescopes that could see the infrared light emitted by the supernova. The team of scientists involved in the discovery of DES 16C2NM also had the help of 3 powerful telescopes, including the Magellan Telescope and the Keck Observatory. It took 5 years and more than 500 nights of observation to identify this distant supernova, which was a great challenge. However, the team's efforts were worthwhile, as the great distance of the supernova will allow them to better study and understand superluminous supernovae and the causes behind these massive cosmic explosions. A supernova explosion of the magnitude of DES 16C2NM or any other Type II supernova would have significant consequences for the surrounding galaxy, and potentially even for the entire universe. This explosion would release an enormous amount of energy primarily in the form of neutrinos and photons, which would interact with the surrounding gas and dust to create a shockwave that would travel outwards at speeds of thousands of kilometers per second. This shockwave would cause the surrounding gas and dust to heat up and emits a burst of radiation that would be detectable across a wide range of wavelengths, including visible light, radio waves, and X-rays. In addition to the burst of radiation, the explosion would also create heavy elements like iron, gold, and platinum, which are essential building blocks for planets and life as we know it. These heavy elements would be dispersed into the surrounding galaxy, enriching the gas and dust and providing raw materials for future generations of stars and planets. Overall, a Type II supernova explosion like the 16C2 and M would have far-reaching consequences for the surrounding universe and would play a crucial role in shaping the evolution of galaxies over time. Through analysis of the ultraviolet light emitted by the SLSN, scientists can determine the amount of matter produced and the temperature reached in the explosion, which is crucial to better understand these events. A difference between that star with Rouge is their type of supernova explosion. The 16C2 and M is a Type II supernova, which occurs when a massive star runs out of fuel and collapses on itself, causing a catastrophic explosion. Rouge, on the other hand, is expected to eventually become a Type II supernova, but it is currently classified as a red supergiant, and it is likely to explode as a Type IIp supernova, which is a less powerful and less catastrophic type of supernova. A supernova explosions of the magnitude of the 16C2 and M or any other Type II supernova would have significant consequences for the surrounding galaxy, and potentially even for the entire universe. Now, experts are looking for other distant supernova, and the ones that are likely to be discovered in the future. What do you think lies beyond the edge of the universe? Let us know in the comments. Remember to like this video, subscribe, and turn on the notification bell. Thank you so much for watching. See you soon.